Let's do it, man. Let's just go quickly through the slides. They tell the story a little bit, and then we can pop into the fine tuning code and look at
Right.
more Hugging APIs.
And this is the last part of the workshop as well.
Yes, yes. And this part's going to be a little hands off. Like we'll do full on fine tuning workshops in the future where
Yep.
this is very hand wavy, to be honest. Cool. So fully custom LLM now. We're like changing the dynamic of this picture by making everything dark purple. Where what we mean is basically like if you have enough relevant data and you have enough compute capacity, you can make your own model. Just do the pre-training part yourself. And the idea is that hopefully if you had enough relevant data that's within the distribution you care about when your users are going to be interacting with the model and your product, that would produce the highest quality of relevance responses. Now, in reality, like getting that much data and training a model that size, there's only a few organizations in the world that can do it. And they're training on data sets that are like the entire internet. So it's like kind of subject or like suspect, in my opinion, to say that that's going to be super relevant to anyone when it's that general. It's almost a built-in trade-off. Now there's this other world of like fine tuning where it's like you have a data set, maybe your data set is quite a bit bigger. It's like 5 to 10 times bigger, maybe even a couple orders of magnitude bigger than the kind of data sets we're talking about with RAG. Or maybe not. Maybe some models like you don't need that much data to do fine tuning. It's really a case by case basis. That's worth studying as a data scientist if you're into this stuff these days. But what you can do is you can actually keep training the LLM. So you're not pre-training. You're taking like a fork or a transfer learning. This is like a variation on transfer learning. You're taking a fork of the model's state and you're saying like, okay, now here's a new data set. Maybe it has a little bit of different shape, or there's like this trend called instruction tuning, where you format the like labeled examples that you give the LLM very specifically. And then you use that to continue training the model. So you're actually updating the weights, the parameters of the neural network. Of course, you could also combine this with RAG. So there's like a lot of interesting research around this. I've even seen like RAG being combined into pre-training as like a recent project from NVIDIA. So there's like a whole bunch of different combinations is the point. But the core idea of what we were talking about here is more this case of fine tuning, where it's like, I actually want to change this blob and make it more dark purple by training on my data, training on a specific shape of data that I think is relevant to our apps and use cases, things like this. So how do we actually do this? There's a ton of good examples on the internet these days. But one way is you can define your model scripts. So this is not too different from a Google Colab notebook I found on the internet. Just like slight refactoring and a little bit of like adding a little extra optimizations on it. It should be runnable on a single V100 if you have a V100 GPU. And what it's doing is fine-tuning a Q-LoRa of the 7 billion parameter Llama 2 model. So that was a bunch of jargon. I think maybe we should talk about Llama a little bit, Hugo. Do you want to like say a few things about kind of the Llama model family or anything come to mind there?
Well, yeah, I mean, a short introduction to everything you just said is Llama's a family that was open sourced by Meta, AI, pretty hefty, big models. I mean, there's a range. But did you say 7B?
Yeah, this one's the small one. The 7B
Yeah.
is the
So,
small.
but it's still big, right?
It's
And
still yeah.
and so, then what LoRa does, it's a form of dimensionality reduction. It uses linear algebra essentially to reduce the size of it in very clear ways. The clever ways, sorry. The Q is quantized. Which is a technical detail I don't think we need to get into at the moment. But that's kind of, I suppose, my very TLDR on what like Q LoRa on Llama 7B, Llama 2 7B would mean or something. Is there anything else you'd add to that?
No, I think that's great. So like in addition to like adding a little bit of stuff from the Colab notebook I found is like the framework
But
we're
also,
using.
I'm sorry, yeah, to your point though, even though we have a small model and we're reducing it even more, we still need GPUs, right? So
Yeah, right. Like this is just not, this one's not very feasible to run on a CPU. It would be like it would take way too long for the model to learn anything for that to be really worth your time, or honestly, it might even be more expensive because you need the computer to be running long. Okay, anyways, basically what's going on here is we're sort of refactoring our custom data set. We're pulling this nice instruction tuning data set that the Databricks team put together called Dolly 15K. And we're kind of repackaging it in a slightly different way. This is what I mean when I was saying, like, you can change the shape of how the model looks to continue its responses by fine tuning. So what you can do is kind of like unpack the data in a specific format that's like how you would want the model to respond at runtime. And then you can kind of curate your fine-tuning data set to be in a shape like this. And it sort of just directs the model about how to respond to things. Like this could be another good use case of like, I want this specific structure only as the output of my data. You just make a really good labeled instruction tuning data set like this could work. What else is interesting here? We see the same API for importing our model. So just like we were doing before in the tinier model use case, like just write in your sandbox notebook with no GPUs or anything. It's the same thing. Use this from pre-trained API. We have our quantization config, and then we're just picking a specific flavor of the llama model. A few other Hugging Face bells and whistles here. Of course, there's the tokenizer piece. And then the API that we're choosing to use is the sort of the highest level API for model training in Hugging Face is this object called the trainer, which takes in another object called training arguments. And this is where we specify a lot of stuff like how to use the GPUs, like kind of what way do you accumulate gradients. You pass in an optimizer so you can kind of like get into this like more like PyTorch layer as well in the trainer arguments. But there's a lot of stuff going on here. And then it's a simple trainer.train. Now, what the kind of the interesting thing, like story-wise here, like we won't really go too much into the code, but we're running this whole script inside of a Metaflow workflow. And one of the reasons we're doing that is because then we can take this model after it's been trained, zip up the whole resulting QLoRa and push it to S3. And Metaflow makes this very easy to kind of like wire this up when we're running it inside of our workflow. And like specifically, like look at how a few lines of code is inside of our Metaflow structure, where we're using the @Kubernetes decorator and the @PyPy decorator that Hugo mentioned earlier. And yeah, we're just kind of making it all happen so that we can then unpack that model on the server and actually run this on a Triton inference server in this case, is what the example shows here. Super high level introduction to the fine tuning and serving aspect of this workshop. Hugo, I think we should probably do a full workshop just on probably each of those pieces independently at some point.
I was just going to say that. And the reason we've decoupled it like that is all the code we've run so far, you've been able to do in the sandbox, and with you know, relatively limited compute and time. Whereas this, you'd need pretty significant hardware as well. So, you know, that's why we wanted to do it this way. But hey, so it looks like we're going back to the Argo workflows.
Yeah, quickly before my battery actually dies, we can see that this first workflow ran. We can go back and see that our second workflow also ran to completion, again, automatically triggered. And our third workflow is now in flight. It finished the start process. Right now, it's kind of doing the heavy compute step, which is actually computing the embeddings and all the Metaflow documentation. And then it's going to push those into the Pinecone index. So that pretty much completes the story, and we're out of slides and out of code in the sandbox so far. Any thoughts, Hugo, to wrap up the session?
Look, I'd actually just like to go back. I'm going to share my screen again and just go back to our can you see my slides? Our slides?
Yeah, I'm gonna quickly move and just make sure I can go get a charger before my thing dies as you're doing this.
Sure. What I wanted to do is just go back to when we talked about, just to remind you everything we've done, and if you coded along everything you did, which, you know, everyone should be super congratulated. You've learned and played around with hitting LLM APIs. You've gone through and thought through with us how you can be more flexible with open source software models. Thinking about RAGs, had a great ragathon, and thinking about better relevancy there, going through the Metaflow docs, which was super fun. Then productionizing rags, then also going through, this is the code we didn't execute, but going through fine-tuning a custom LLM. So all in just over a couple of hours, you know, and if you did this at 1.5x under a couple of hours, you've managed to learn a huge amount about the space. As I said, in the description, we'll put the link to our Slack community where we love chatting about all of this type of stuff. Very much welcome feedback. Anything else you'd like to see in the sandbox, we'd love to show you and produce at some point as well. But I think with that, that's a really nice note to wrap up on. Eddie, what do you think?
Sounds great. It was super fun, Hugo. We should definitely do this more often.
That was an incredible amount of fun, and thank you all for watching and sticking around until the end. And we'll see you on Slack. All right, ciao.
Yeah.